Okay, let's look at the homework 11, problem number 4. Alright, and this is part B. Alright, let's find the eigenvalues and the eigenvectors of this matrix. Alright, first thing we should do is we're going to have to solve this equation. So determinant of, we're going to subtract lambda from the diagonal element. So it's going to be 2 minus lambda. And you're going to have another 2 minus lambda, and you have a 1 minus lambda, right? So, and everything else stays the same. You have a 3, 0, 3, 0, 0, 0, right? Then we want to find the determinant of that, right? So since we have, let's see, luckily we have 0, 0. So I'm going to use, let's see, I'm going to use probably this guy right here. So I'm going to expand along the third column, all right? So this is going to be equal to, all right? So let's see, this is going to be positive, negative, positive, negative, positive. So this is positive. So positive. 1 minus lambda times, then we're gonna eliminate the third row and remove the third column, and this is a submatrix, so it's going to be a determinant of the submatrix 2 minus lambda, 3 and 3, and you have a 2 minus lambda. Right, so we have that. All right, then I would just compute this. This is 2 by 2, so we can just do these this times that. So this is going to be equal to, right, 1 minus lambda. Right, so you're going to have, let's see, I'm going to just go ahead and multiply out. So this times that, so that's going to be 4 minus 4 lambda plus lambda squared, right, minus 3 times 3, so minus 9, right? So we have that. Actually, I'm gonna just erase this guy. Whoops, I'm gonna just erase this, and I'm gonna put a parenthesis there, parenthesis, right? And clean it up, you will end up getting, so I'm gonna go down here, right? So you have a 1 minus lambda. So this is nice, right? So this is going to be, you have a lambda squared and a negative 4 lambda, right? Then you have, let's see, 4, this is minus 5, so it's going to be negative 5, right? And we can further factor this out. So you have a 1 minus lambda, right? Then you have a quantity here and a quantity there, right? So you have a lambda here, lambda here, right? So this is going to be, let's see, plus 1 and minus 5 would probably work, right? All right, so we set that equal to 0. So we want this determinant to be 0, right? So this will give you 3 eigenvalues. Let's see, I'll use the smallest one. Smallest one is going to be lambda 1 is going to be setting this guy equal to 0, so negative 1, right? And lambda 2 would be positive 1, right? And lambda 3 would be 5, right? Then for each lambda, we should be able to find the corresponding eigenvectors. So I'll just do one of them, right? So let's do lambda 1, right? So you have lambda 1, which is negative 1, right? Right? Then, so we're going to plug the lambda value back in here. So you would have this equation, matrix equation. So you have matrix, right, 2 minus negative 1, so you're adding 1, so it's going to be 3 here. And you have a 3, 0. and you have a 3, and this is 2 plus 1, so it's another 3 here, and you have a 0 here, right? And you have a 0 here, 0 here, right? 1 minus negative 1, so this is going to be 2, right? Then what we can do is we can just row reduce this easily. So you can see that first I'm gonna just subtract the row 1 and from row 2. So that way you're gonna get maybe I'll write it here, row 1, right, subtract row 2, and that's going to be a new row 2, right? Then you will get a matrix which looks like this. So it's a 3 minus 3 0, 3 minus 2 0, 0 minus is 0. So you have, and also I'm a little lazy, I'm going to go ahead and divide through by, so multiply row 1 by 1/3, right? I'm going to go ahead and do that. That's going to be 1 1 0, right? Then I'm going to divide this guy through by 2, so it's going to be multiply row 3 by 1/2. That's going to be row 3, so it's going to be 0 0 1, right? And if you want, you can switch row 1 and row 2 and row 3. That way all the zeros is on the bottom. So 0 0 row. It's going to be on the bottom, so it's going to be 0 0 0 on the bottom, right? Then you have a 0 0 1, and you have a 1 1 0, right? So this is row reduced, right? Right, so this matrix corresponds to this equation. So you have x, right, x1, y1, say z1, right? So that's the eigenvector for corresponding to lambda 1. So this has to be equal to 0, right? So you're going to get 0 0 0, right? Right, so which means that we have the following equations that we need to satisfy. So top one, we have equation x1, so I'm doing the row 1 times this guy, so plus y1 and equal to 0. Alright, second row tells you that it's just going to be 0 x1, 0 y1, and 1 z1. So z1 is equal to 0, right? And from the top equation, this is going to give you x1 has to be negative of y1, right? And those are the only conditions that we need to satisfy. So you can see that, okay, z component has to be 0, right? X component has to be the negative of the y component, right? So which means that we can take eigenvector v1 to be, right? So z component is 0, so we already know that, right? Then you can probably give y a 1 or something, and then x has to be negative of that, so it's going to be negative 1, right? Or you can give y negative 1, then this would be a positive 1, right? But anyway, so this is the eigenvector that we're looking for, right? Corresponding to eigenvalue negative 1, right? So these are all the eigenvalues. All right, then I'm gonna stop here. So I think you can do find eigenvectors for corresponding to lambda 2 and a lambda 3 in a very similar way. All right, that's it. I hope that this was clear.